Hey everyone, this is a quick answer key. I am doing this on the fly, so if I encounter any problems, I'm just going to talk through it and make corrections. I can't redo this one. Anyway, it says, which of the following are polynomials? If they are, give the degree and put them in standard form. If they're not, all you have to do is circle the part that ruins it. You cannot have negative exponents. That's actually division by x, so it would be 1 over x to the 4th power. Can't do that, so that's no good. This one, you can't have decimals either. They've got to be whole numbers that are non-negative, so that's no good. This one here, ooh, that square root does not go over the x. That's okay, that's just a weird number, but it's on the real number line. 3.33 also, that's just a number. No problem with the x's. So this is this in standard form? Yes, it is. It's in declining exponential power. And so it is in standard form already. Otherwise, you'd have to rearrange it to be that. This one cannot have an x up there either. No variables up in the exponent, so these are no good. All right, then on to this. Sketch and identify all the key parts. Okay, so when you look at this, it's really hard to sketch without knowing sort of where the zeros are. So I'm going to start factoring things out. There is an x everywhere. If I take out an x, then I get 2x to the 3rd minus x squared minus 8x plus 4. Now I'm looking for ratios and hoping that maybe there's something common and I could factor by grouping, and sure enough, this is a 2 to 1 ratio, 2 to 1 with the signs being different. So I can then say it's x, and then I've got x squared I can take out, no numbers. If I take out an x squared, what's left behind is x minus 1. And then here, if I take out a negative 4, what's left behind is x minus 1. Now you can always check by bringing that back in, and I'll get the same thing. I'll get, oops, sorry, look at that, be careful. I'm writing and not being careful. I hope you spotted that. You're wondering what's going on. When I take out an x squared, of course I have 2x, all right? So I was just checking myself and I caught my error. So that is a good thing that you guys can do too. Whenever you do it, just quickly check and see, do you get what you had before? A minus times a minus will give me a plus 4. Now I can factor out this, and so I get x as one factor. I get 2x minus 1 as another factor. I get x squared minus 4 as the remaining parts, and then of course this I can factor. I'm going to cross that out and write it just so I don't have to rewrite it, x minus 2 and x plus 2. Now to make a graph, I'll maybe sneak it up here because I need room. I have zeros at 0. I have a 0 at 1/2. Don't just look at this and do the reverse. It's not just positive 1. I have to set this equal to 0, move the 1 over and divide by 2, positive 1/2. I'm going to go, there's 5. So positive 1/2 is right there. Then I've got 1 at plus 2 right there, and 1 at minus 2 right there, and that works. So it's going to be a 4th degree polynomial. We know it's 4th degree, so I'm going to degree is 4. That's even, wouldn't hurt to say that. My lead coefficient here is 2. Okay, so my end behavior is going to be up and it's even. So it's going to go up and it's going to go up, and then each one of these is going to go through. There are no bounces, no duplicates, something like that. Okay, you just need a pretty good approximate graph. So I'm going to use same kind of logic here, and the constant term of course is 0. The y-intercept is 0. Y-int equals 0. These are the zeros. I would list them. I'm just trying to talk quickly, but you could list the zeros for the for each of these, right? We'll do that here. Maybe here I've got just a little graph I can draw. My zeros are at positive 1, 2, 3, at negative 6, 1, 2, 3, 4, 5, and 6, and then also at 0 right there, like the last one. This has got a multiplicity of 2, so at 3 it's going to bounce. It's either going to go like this or like that. Here it's a multiplicity of 3, so it's going to do a swoop. It'll either go from high to low with an S, from low to high with an S, like that. Maybe that's a little misleading because I'll put arrowheads on these ones just to identify that would be one swoop. Okay, and then it's going to go through the 0 like this. So let's look at the end behavior. 2 plus 3 plus 1 is 6, so degree of 6. Again, it's even. The lead coefficient, if I look at the coefficient here, it's going to be a positive 1 in this case, so it's going up. So I know it goes up like this. That means it has to bounce. It goes through once, and then it's going to do the swoop like this, like I had suggested there. That was getting a little lucky. Okay, so that's the basic idea there. LC equals 1. And the right-hand behavior, if we had to talk about behavior, you could of course say as x goes to infinity, g of x also is going to go towards infinity. It's just about up on the right as x gets big. X goes towards negative infinity on the left. G of x is going to do what? Oh, it's also going up. So just make sure that you also show it going up. All right? So one like this then, same thing, only slightly different. I'm going to sneak it in right here. I've got, again, 1, 2, 3, minus 5, and then 6. And then now what's going on here? X is in like the wrong place. Really, this is minus x plus 5. Oops, minus x plus 5. Can't talk and write at the same time. If I take out a minus sign, I would get x minus 5. So really, this is written in normal style with an x outside. That means my lead coefficient is going to be negative. In this case, it's going to be negative 1. So my lead coefficient is equal to negative 1. So my right-hand behavior is going to be down. 2 plus 2 plus 1 is degree of 5. My end behavior is opposite. So I want to get all my zeros in. This one, the 0 is still going to be at 5, 3, 4, and 5. Because when I substitute 5 in for x, then they subtract. That's a 0. But I know that my end behavior is down on the right with a bounce there at 5, so it goes like this. And then at 6, it's a bounce, and it's like that because it has to go through this one time and ends up and then comes like that and then bounces. And then what is this point here? We can solve by plugging in 0. When I plug in 0, h of 0 is going to be minus 3 times 6 squared times 5 squared. When I plug in 0, that's subtracting a 0. So what is that? That's going to be minus 3 times 36 times 25. Okay, well, 36 times 3 is going to be 108. And times 25, that's going to be up in the thousands, all right? So for now, I'll just make that 2,000 or so. And you can put that on Desmos and get it more exact. Get a calculator, multiply that. Again, I'm in a hurry, so I'll get on to this one. Now here, we're looking at the picture. I see a single 0 there. I see a bounce there. I see a multiplicity of 2 there, and I see a single 1 there. So f of x then is going to be equal to, this one would be x plus 2, of course, to give me that minus 2. No bounce. This is going to be then x minus 3, and I bounce it there, and then x minus 5, no bounce. Okay? Now, write the equation. Is this the perfect equation? I do want to consider what this point is, and right there, that looks like that's going 2, 4, 6, 8. When I plug in 0, what is f of 0? I get 2 times negative 3 squared times negative 5. What does that work out to be? That works out to be 2 times 9 times negative 5. And negative 2 and 5 make negative 10, so that's equal to negative 90. I think I misspoke before. Did I say that was 8? That's 5, 6, 7, 8, 9. So you'd expect this to go through negative 90, but it's going through positive 90. So that means I've got to take this whole thing and switch it upside down. and then divide it by 10, all right? So let's see. Right here, I will then switch it upside down by taking, like I did up above, see how it's 5 minus x? I can either put the minus sign out in front. So f of x is going to be equal to minus, and then I want to take 90 and make it go down to 9, so I'm going to be 1/10, and then x plus 2, x minus 3 squared, and then x minus 5. If you want to take away that minus and then make this 5 minus x, like the one up above, you can do that, okay? But finding that 1/10 is requiring you to do a little bit of application from last unit where you're scaling it up or down. If you had just some number come out that wasn't so conveniently divided by 10 to go from 90 down to 9, you just would be like, oh, when I plug it in and I get something like 13, and here I want it to be 7, you'd be like, oh, I know that it's going to be 7 times a is going to give me 13. I would just divide both sides by 7, and I'd say, oh, my a value, my fraction out in front, is going to be some fraction like that. All right? Complicated, but that's the final detail. Good luck, everyone.